So we will discuss about what are the modules and what are the things are used for the ECG training module. We will use the database of MIT BIH, basically one of the best AI and health research datasets. So we will use four libraries basically and five libraries here. First is NumPy and Pandas, which is used for numerical operations and handling dataset. Matplotlib for plotting and training the graph and accuracy. SkyPy and Pivot for the signal processing. Skitlearn for splitting and balancing the dataset. Keras and TensorFlow for building and training the deep learning models. Now we will think what basically we will do. So we will download the MIT-PH dataset and we will initialize with path and window size 180 and maximum counting 10,000 is basically we will use the 180 size windows basically array. We will take in 180 elements at once and we will classes. There is a 5 classes present in our dataset: N, S, V, F, Q. N is normal basically and 4 types of basically ECG problems we have listed it here. We have mentioned the classes and the multiplication counts classes ki how many classes are there. Then we will use split the dataset into CSV and TXT file. You will see it here. This is the CSV and TXT differentiation files. Now we will manage and records all the annotations files and the records files, which is a record file as a CSV files and annotation files as a .txt files. Then we will come to the importing and everything. We will make a directory against and we will import all the things. Now we are using three denoising systems. Basically we have a noise in the many images, so we will denoise it using the decompose signal, sort thresholding and reconstruct signals. We will do these three things for denoising this. Then we will get all the CSV files basically and we use the 5 here for best prediction and 6 here. We will use the multiple files and you will add in the annotation files and train it. So we will use the CSV files, then we will adjust the window size. Window size is 50. We will not take the 180 window size. We will decide to 50 window size. Then for example, we will use some of the arithmetic classes just like 5 and 6. We will use this further. Then we will process it and records all the notations and CSV files. So we will debug it and we will show all the graphs. You will see it here. This is a sample milli VS5 CSVs, basically ECG, it is shown here. Now let's talk about what are the basically difference and everything we have to do it here. This is basically a timing output and sub chain output and everything is present in the for the 6 files which we use to train it. So we basically we will process the 6 ECG CSVs. X-shape beats extraction is 13,320 amongst 100 and arithmetic levels are 3020 and not defined here. So we will use the print. What is the shape of basically we have to train and what are the shape of the CSV files. So we will do this. Next we will use the pandas and wildlife three libraries. We will train for the 5 classes because we know that there is not a 7 classes. There is only a 5 classes in the ECG N, S, V and FQ. So we will use this to denote the different colors for different levels. For N we will use the blue color, for S we will use orange color, we use V for the purple colors and F use for olive color and Q use for green color. Then we will make the graph which will represent the MX6 trained file. What are the accuracies of the ECGs? So basically in 68.6% we will get the normal ECG 5.4 Q, 25.6 F and S and V as 0.3 and 0.2%. Now we will do the data frame. Data frame is basically to matching the columns and frame the data according to our needs. Then we will use the originally princess size and we will utilize it to manage the more pattern and make all this is of the same size and we will reframe it. Then you will see the original size is 3 and the new data frame size of the 3 samples is 6. Okay, we will make it larger and smaller and all the data frames into a same segment. Then we will again print the same thing. There is not any difference, so we will easily view it. Now let's take about the training and splitting dataset. We will split the dataset into training and testing part. Training we use the 10,656 images data for the testing 2,624. We will print it, no issues. Then we will print it also testing and training size. So for the testing and training we will initialize our for x is the basically independent variable. For the dependent variable we can't define it. So we in the next we will define for the basically for the dependent variable which is y. So basically for y we will use 10 10. Then we will test and train. Furtherly we will do the classification and make the reshaping of the data things, how it is processing. Then we use a sequential layers. What are the sequential layers and how we will use? There we use basically convolutional layer, max pooling layer, and dense layer and dropout layer. So let's talk about the layers one by one. What are the layers used and why it is? We use convolutional 1D, basically 64 filters, basically which work as the extracting low-level ECG features like edges and peaks. Max pooling layer is used for basically reducing the signal length and dimensional reduction. Then we will talk about the patch normalization. Basically, patch normalization is used for stabilizing and speeds up training. Then convolutional 1D 128 to 56 used for deeper features. Basically, we will use 120 or 40 also. So which is used for the learning the complex heartbeat patterns. Flattened layer, basically flattened layer is used for the converting the 3D features and maps into 1D. Dense layer is used for the learn the global signal representation. Basically, dropout layer is used for the prevent overfitting, and dense basically the softmax and dense layer, which is combination of in the last we will use it. It is used for the gives the probability distribution across the heartbeat classes. Now we will see the further. We will combine the categorical data. We will give the shape of all the testing and training data sets for independent and dependent variable. Then we use the CUDA function. Basically, we use the GPU for training this, but my laptop doesn't support the GPU, so we'll use the CPU to train it. We use the number of epochs as 60. Why? We have to train multiple times to get the better accuracies of this. So at the final stage, we will get the accuracy of testing accuracy is 68.29. So we will process it again with the minute differences. We will use the flatten and normalization also for denormalization and converting the labels into categorical data. And we use activation function in the above is softmax. Now we will use the activation function ReLU and dense function at the normal round is used for the softmax function. Then we will again train it and we have the batch size of 36, epoch 16 and verbose 1 and validation testing and recording. So we will train it and we will get the better accuracy and validation accuracy is 97.6. That is quite more better than this. So we will use the presentation training and validation loops. Now we will showing the all the loops and predictions. Basically it is an accuracy and validation accuracy prediction epochs. Now we will process it and we will make a 3-odd matrices which is showing in that this 0.01 and the array is basically float 32 point version. Then we will print the testing and training accuracy. Test loss is 0.21% and test accuracy is 97.96%. So overall we will get the best accuracies for this. So this is the conclude video of ECG training, how it is that we train, and it is basically on the test bed processing. So by this way, we will implement and increase the accuracy of the models which is predefined, and we will use a hyperparameter tuning as everything we have changed, and we will get a more accurate and better result in this. Thank you so much, guys.